Hi guys, in this lesson I'm starting with section 2 of complex numbers. Let's begin. So the first point of this chapter is Argand diagram and how do you make that? So guys, complex number is given to us a plus bi where a is the real part, that's what x-axis, and b is the imaginary part, that's what y-axis. So imaginary is I am and real is this one. X-axis is real and the imaginary one is y-axis. Now I need to draw this Argand diagram. So let's begin with that. So guys, it says 3 plus 4 iota. How will I draw this? So 1, 2, 3, 4. 1, 2, 3, 4. So it says 3 plus 4 iota. That means 3 on x-axis and 4 on y-axis. So will this point will be 3 comma 4. X पे 3 and y पे what guys? 4. So my Argand diagram will be this. Got this? Then it says 3 and minus 4. So it's 1, 2, 3, 4. 1, minus 1, minus 2, minus 3, minus 4. So 3 and minus 4 iota will lie here. 3 on x-axis and minus 4 on y-axis. Got this guys? So it's going to be bache this as your Argand diagram. Do you get this bacho? 3 and minus 4. So are you clear with making Argand diagram? Now comes the first point of section 2. That's what modulus. Modulus is the distance from the origin. Let's suppose 3 plus 4 iota का modulus ढूंढना. So 3 plus 4 iota lies here, right? Here. So modulus is this the length of this Argand diagram. So guys, the formula of modulus is under root a square plus b square. Sir, what's the logic behind it? So if you see, how will you get this? Is this the hypotenuse? What's the formula? 3 square plus 4 square is equal to x square. That's how you get the hypotenuse. So based on hypotenuse formula, you get the modulus as 9 plus 16. That's what? 5. So modulus is basically the hypotenuse formula because modulus is the hypotenuse of Argand diagram. So it's going to be 3 square plus 4 square, that makes 9 plus 16, that's under root 25, that's what? 5. Here it's going to be minus 1 square plus under root 3 whole square. So that's going to be 1 plus 3 under root 4, that's 2. Here it's going to be minus 1 upon 2 square plus minus under root 3 upon 2 square. That's going to be 1 upon 4 plus 3 upon 4. So that's going to be under root 4 over 4. That's 1. So what's under root 1 ka answer? That's 1. That's how you find modulus. Now comes the second point. That's what argument. What's the formula of argument? It's tan inverse b upon a. Sir, what's the logic? Because it's making a right angle triangle and you need to find the angle. That's why. So let's begin with what is argument with the fourth example. But the first thing, what is argument? It's the shortest angle from the starting point. And what starting point? It's this line. Okay. So now let's begin with it. Just let me add one more point. If you go anti-clockwise, the argument is always positive. If you go clockwise, the argument is negative. Let's start. So 1 plus under root 3 iota. It's going to lie where? So 1 will be here and under root 3 will be somewhat here. Okay. So this is my Argand diagram. Now the argument is shortest angle from the starting line. This is a starting line. So to reach the Argand diagram, one way is this one, black one. And the other way is to go clockwise and reach here. Guys, which one is shortest? The black one or the purple one? So the black one. So my argument will be this black angle. How will you find that out? So if you notice, this is making a right angle triangle. This is under root 3, this is 1. So I'm going to apply tan theta is equal to under root 3 upon 1. That's going to be pi upon 3. Do you all get till this point? Now the other example. So it's what? Minus 1 plus under root 3. So it's going to be roughly here. So this is my Argand diagram. Now we need to find out the shortest angle from starting line. This is starting line. So one option is this one going anti-clockwise. The other option is this red one. Which one is smaller? So the black one. So my argument will be the black angle. Do you get this? Now, how will I find that out? So if you see, is it making a right angle triangle? Yes, sir. So my opposite is what, बच्चे आपका? Sorry, my bad. So if you notice this, can you find this angle easily? Yes, sir. Opposite is under root 3 and adjacent is 1. Let's apply that. Tan theta is equal to under root 3 over 1, that's pi upon 3. So this angle is pi upon 3, but you need this part. You need this part. How will you get this? One straight line is what? Pi. So in order to get this part, it's going to be pi minus pi upon 3. That's what? 2 pi over 3. Do you get this? I have made this here. Pi minus theta. Do you get this? If it lies in the second quadrant. Now comes this third one. Minus 1 minus under root 3. It's going to lie where? It's going to lie here, minus 1 and under root 3. Somewhat here. Okay, guys? Now, to reach this point, this is our starting line. One option is go this way. The other option is go this way. Which one's smaller? The red part or the purple part from the starting line? So the red part. So that's my argument. But in this part, I'm going clockwise. Keep this in mind. Let's find angle first. So guys, this is under root 3, that's 1. Tan theta is equal to under root 3 upon 1, that's what? Pi upon 3. But I need this part. So it's going to be pi minus pi upon 3. That's going to be बच्चे आपका 2 pi upon 3. Now you are going backward in clockwise direction. So it's going to be minus 2 pi upon 3. Do you get this? When we go clockwise, the argument is negative. Let's do one more example. Here, 1 minus under root 3. Where will it lie? 1 and under root 3. It's going to lie here, yes or no? So guys, one option is this one from the starting line. This is starting line. And the other option is going anti-clockwise. Which one is smaller? Set the clockwise smaller. So remove this. So just find this angle. How will you do that? So guys, opposite is under root 3, adjacent is 1. Let's apply tan theta is equal to under root 3 upon 1. That's what? Pi upon 3. But you are going clockwise direction. So it's going to be negative pi upon 3. So clockwise में argument negative होता है, anti clockwise में argument positive होता है, and it is the shortest angle from the starting line. Let's do more example. So it's written 2. 2 means that it lies here. Okay, that means on the starting line, on this point. So my argument will be बच्चे on the starting line, that's 0. Minus 2. So minus 2 lies where? It lies here. So 1 from the starting line, you can either come clockwise or you can come anti-clockwise because both are same. So the answer will be either pi or minus pi. Got this? Now it's 2 iota. 2 iota lies where? It lies on the y-axis here. So now one option is this one from the starting line and the other option is this one. Is the black one angle smaller or the red one? So the red one. So my argument is this. So now argument will be pi upon 2 and you are going anti-clockwise, that's why it's positive. Get this? Now minus 2 will lie where, guys? It's going to lie here, right? You need to come to this point. You can either take this angle or the red one. Which one's smaller, the red or black? So the black angle from the starting line. This is starting line. So you are going clockwise direction 90. So you're going to write minus pi upon 2. Do you get this? Here we complete the modulus and the argument. Here's one example. 10 pi upon 9, that's roughly 200 degrees. Okay, let's draw this. So my 200 degrees will lie somewhat here, yes or no? But if you are asked to find the argument is the shortest angle from the starting line. Is the red one shorter or the black one? Said the black one. So what's 360 minus 200? That's 160 degrees. So 160 degrees to convert to radian. So if pi is equal to 180, 160 is x, cross multiply, guys. It's going to be x is equal to 8 upon 9 pi. Do you get this? Here it's minus 190 degrees. That means it's in the clockwise direction. Got this? So minus 190 will lie somewhat here. But if you are supposed to find the argument that's from the starting line, is the black arrow smaller or the red one? So the red one. So if this part is 190, what 360 minus 190 is? That's 170. So if you convert that to radian, it's going to be x. Do you get this? So my answer will be 17 upon 18 pi. Do you get this, guys? So that's how argument is done. Now come modulus argument form. It has two forms. The first form is r cos theta plus I sin theta. To memorize this, you can do with this word r cis theta. And the other form is r e iota theta. Examiner will either ask you to write in modulus argument form, or he will give you the modulus and argument and ask you to find the complex number, or he will give the form he wants in either this one or this one. Got this? Let's do this one. 1 plus under root 3 iota. So its argument we find earlier was pi upon 3. How? If we draw this, it was here 1, and under root 3 it was here. So tan theta is equal to opposite over adjacent. That was pi upon 3. Got this? Now, r, let's find that. Under root 1 square plus under root 3 square, that's under root 1 plus 3, that's 2. So in modulus argument form, you're going to write 2 cos pi upon 3 plus I sine pi upon 3. Do you get this? In the other form, you're going to write 2ei pi upon 3. Do you get this? Different type of question can come like this. Let's suppose examiner give you that the modulus is 2 and the argument is what? Pi upon 3, and they ask you the complex number. So you're going to write the modulus argument form में cos pi upon 3 plus I sine pi upon 3. First you write like this. Then what's the value of cos pi upon 3? Find in the calculator. That is 1. And what's the value of sine pi upon 3? That is, so cos 6 is 1 upon 2. It's 1 upon 2 plus, and sine pi upon 3 is under root 3 upon 2. So if you multiply this, you're going to get 1 plus under root 3 iota. Is this the same complex number? So examiner can ask you to write in these form. They'll either give the form like write in this form or re iota theta, or they'll ask you to write in modulus argument form. First thing. Second thing, examiner might give you modulus, might give you argument, and will be required to find complex number and solve further. You get this? Now comes the application of modulus argument form, which I'll explain in the next lesson.